Hi class, this is a review of the part 1 of Lab 1 in case you missed it on the first day. So our first page of Lab 1 is going over the scientific method, which is what we did in lecture. So feel free to read that again. We did talk about it in lecture. And then our second page is giving you a review of scientific graphing. Got a lot of students who haven't been in school for a while, so this is just reviewing for you what a line graph is and then what a bar graph is. So very good to go ahead and read that by yourself and review what those two graphs are. Now if we look at activity 1, that's what I want to go through in this video. We're going to pretend that we have done this experiment where the question we're asking is, will adding fertilizer to plants make them grow taller? So I'm going to give you the data for this, and we're just going to make sure everybody knows what to do with data, how to average data, how to graph data. Okay, so our question is, if we add fertilizer to plants, will they grow taller? So the first question that is asked here is, what is a control group, and why is it important to include when one conducts an experiment? So the control group is the group that we don't do anything to. Okay, this is the group. It's going to match the experimental group except for one variable, and in this case that's going to be adding fertilizer. So this is a group that we compare to. So the shortest answer is the group that you compare to. You don't make any changes between this group and the experimental group except for one thing. So which group of plants above is the control group? That's going to be the non-fertilized ones. God, this is going to take too long if I'm trying to type. So I'm just going to say it instead of typing it every time. So which group of plants above is the experimental group? That's going to be the one that we're adding fertilizer to. So independent variable and dependent variable, we went over this at the end of chapter 1. So independent variable in a science experiment is your input. You can think independent, your input. What are you doing? So the independent variable is going to be adding fertilizer. The dependent variable is how are you going to determine the difference? So are you going to measure? Are you going to observe something? So the dependent variable in this case is going to be measuring the height of the plants. So now continuing talking about the planning in our experiment, what are 3 variables that need to be identical for all 20 plants? So we're going to have 10 plants with fertilizer, 10 plants without fertilizer. What do we need to keep the same between all 20 plants? So you're going to want to keep the same sun, the same soil, the same amount of water. You want it to be the same plant. So all of these variables need to be the same, and the only difference is going to be adding that fertilizer. So our next question asks, why is it important to keep conditions exactly the same in the control and experimental groups? Because otherwise you're not going to know what it is that caused the change. If you stick one group of plants in the sun and the other group in the dark closet, and you're also adding fertilizer, you have too many things that are changing between the two groups. So it's important to only change one variable, which is adding fertilizer. The next question is about sample size. Why is it better to do the plant fertilizer experiment with 10 plants in each group instead of just 1 or 2? Well, if we look at the data that's already been set out for you, we can see that plant 9 died. So that might just be an outlier, like it had a disease or something happened to it. So if we had used only that one plant, we might come to the conclusion that without fertilizer, plants die, but that would be incorrect. So if we increase our sample size, we're going to have less effect by outliers, and we're going to have greater statistical accuracy. All right, so now if we look at our data, what are we going to do here? So when you have a table of data like this, we're going to want to look at the average, because if we look just the week 1 growth, we've got 9 plants now. They varied from 1.5 centimeters all the way up to 4. So which number are we going to use? The highest, the lowest? What we're going to do is we're going to average. So what I'm going to do is add up this column of numbers, divide by 9, because we have 9 plants now, because that one died, and then we're going to have an average. So I'm going to go ahead and put in these numbers for you. I will type these in. So the average here is 2.4. The average here is 4.6. This average is 7.2. And this average is 9.3. So we're going to be using these numbers in a minute in our graphs. So if we look at table 2, oh yeah, I should say that table 1 is the control group. So this is how much plants grew without fertilizer. And with fertilizer now, we need to do the same thing. But instead of dividing by 9, this time we have 10 plants, so nobody died. And we're going to divide by 10. So you add up each one of these numbers and then divide by 10. So I will go ahead and give you the averages here. This one is 4.4. This one is 9.0. This one is 13.7. And this one is 18.1. It's important to note that I am rounding up. If I have a number that's something 0.5, I'm going to go to the next highest number. And I'm also only going to the first decimal place, because this is the level of accuracy I have in the other data. So I don't want to pretend like I have more accuracy. So now we're going to draw a line graph. So I'm going to switch to Paint. And you would have to look at your data in the 2 tables and decide how big of a graph do I need to make. And I have already made this just to make this movie a little bit faster. But if you look, the lowest number you have is going to be 0. This is growth in centimeters on this axis, and this is weeks across here. So you always start out, in this case, with 0, 0, because we started out with seeds. And the highest any plant grew was 18.1 centimeters. So you want to make sure that you have at least a scale that goes up to 18. Another important thing to do when you're making a graph is make sure there is even space between 0 and 1, 1 and 2, 2 and 3. These all have even spaces, and the same goes for across here with the weeks. There are actually 5 hatch marks to week 1, 5 hatch marks to week 2. A lot of times with beginners, they seem to disregard the space between 0 and 1, and they make that really small. So your graph will not look good unless you have the same spacing between 0 and 1 that you do for the other numbers. Okay, I have this open in Paint, and I'm going to try to do this. So I'm going to start with the data from table 1, and we start out with 0, 0. So let me do a shape, and we're going to go 0, 0, and then at week 1 we go across to week 1, and then it says our data there is 2.4 centimeters. So then we're going to go up 2.4 centimeters, and we're going to make a circle there. You're going to be doing this by hand, and I will give you graph paper whenever we get to meet in class. So now we go to week 2, and it was 4.6 centimeters. So I'm going to week 2, and I'm going up to 4.6, and I'm making a circle there. Now our week 3, we go over to week 3. How much did it grow? I go up to 7.2. And then week 4, you go over to week 4, and then up to 9.3. It's kind of hard to do this in paint. So now you draw a line going from 0 through your points, and you can either make this a different color, or you can write this is the control group, or you can write this is the non-fertilizer group. To make this movie shorter, I am not going to take the time to do that, but I'm going to go ahead and change now to do our fertilized group. So I go to table 2 and I look at my data. Again with table 2, I'm starting with 0, 0. And then it looks like week 1, if I go over to week 1, the data there says 4.4. So I'm going up to 4.4, making a circle roughly there. Now I need to go over to week 2, and I have 9.0. Week 3 data, I go across to week 3, and then I go up to 13.7. And then week 4 data, I go up to 18.1. It's not quite in the right place. I guess I can move it. And then again, I am going to draw a line through my data. And you can either make a key that says the green line is fertilized, the black line is control, or you can write it along here. But because I'm in paint, I'm not going to try to do that. So if we return now to our lab write-up, it says use the graph paper to draw a line graph. So that's what we did. Another important thing to note is that you have both lines on the same graph, so you can actually look at them and compare. You don't want two different graphs with different scales. You want to be able to compare your data. So it says then now to review your graph, were there differences in growth? Hopefully you can tell the fertilized group did grow better than the non-fertilized group. And if you actually look at the table numbers, it's actually roughly double. So summarize the difference in growth. Basically, it grew double. So do the results support your original hypothesis that fertilizer makes plants grow better? Yes. And then a lot of times in our labs, we're going to ask you, why is it more, we're going to ask the same question in different words. So why is it more accurate to compare the average height gain in the control and the experimental groups instead of comparing individual plants? Because you can have outliers. You could have a plant die, so it's more accurate to reduce the number of outliers and to get a better idea of the actual growth. So here we go. Now we're going to look at the data in a different way. We want to see, were there spikes between weeks, like it really shot up in week 3 compared to week 2. So if you read this, this is how we're going to get the data for these two tables, is we're going to take the growth from week 2, subtract from week 1 to get only the growth between week 1 and week 2. And then the same thing for week 3 and week 4. So I'm going to give you the data here. Please ask me in class if you don't understand where I'm getting these numbers from. Oops, not 26, but 2.6. And week 4 is 2.1. Again, these numbers are coming from table 1 and 2, and we're just doing some subtraction here to get how much it grew each week instead of the total number. Trying to fit this into a 20-minute movie. So we have 4.4. So now what we need to do is draw a bar graph. So if I go back to this table and I hit undo a lot, now I'm going to show you how to do a bar graph. So if I pick the shape of a rectangle, it says that our weekly growth rate in week 1 was 2.4, and then it was 2.2. So see how I'm making a bar this time instead of making a point. So week 3, and then week 4. Now if I do, so that's going to be my unfertilized. If I do a bar for the fertilized, I go week 1 to 4.4, week 1 to 4.6, week 1 to 4.7. I changed that to, okay, so my colors are off, I'm sorry. And then we go back to week to 4.4. So I'm a little off here because this should be green. But now we're looking at the weekly growth. And as you can see, the control was roughly the same each week. This one should be green. And the experimental was roughly the same each week. So it asks questions. Do you think there were any differences in weekly growth rate? They were basically the same through week by week. So this very last question, I want everyone to try by themselves to see if they can go through the scientific method. So it's asking you about, you've observed some turtles that are sitting in the sun on a log, and you need to determine why are all the turtles sitting on the logs in the sun. So I have to close up here because my 20 minutes is up. But see if you can do this by yourself. And then we will maybe talk about it if people are having troubles with it. You're going to have to come up with 2 different hypotheses and then design an experiment that will help tell you what's going on. So I hope this helped if you happen to miss the first part of Lab 1.